Hello, my little mathematicians. We're doing some A2 today. Unit 3, Day 7. There is a lot of material here, so please make sure that you are staying with me, and make sure that you watch the whole entire video. Okay, open exercise. We're going to find all the solutions to the equation below algebraically. So if I, just like we had done before, if we had looked at our 4 terms and I had said find the solutions, you're going to factor. And it's a 4 terms, so you're going to group. We're going to take an x squared out of here, and we're going to take a negative 1 out of here, and they're going to both be x plus 3. And I'm going to get an x squared minus 1. And x plus 3, and then I'm going to factor that x squared again, and when I do this and I solve, I got x is 1, x is negative 1, and x is negative 3. So that's my solving, right? We've done this before. Well, we've done the factoring before, and now that we have it equals to a 0, then we just solve. And we did this, we stated this factor theorem, excuse me, before, where it says if c is a root of the polynomial, so like, for example, this is like my c value, right? X equals 1, 1 is my c. Then x minus c is a factor. Right, so for example, when I had x equals 1, the factor of that is x minus 1, right? So this is the factor, this is the root. And at the same time, if it's an x minus c is the factor, then obviously c is the root. Okay? So we're going to use this to help us with our polynomial graphs today. What if you cannot factor using the grouping method? Is there another way to find the factor? Alright, so in this case, let's say we see the 4 terms, we go to try the grouping method, and I pull out a 4x, and I get x minus 2 here, and I pull a negative out, and I get an 11x plus 3, and they don't match, right? So if I had to factor this, we're going to do something a little different. We are going to use our calculators. Okay, you're going to use y. Now, this is the only unfortunate part. With me not being here, I'd have my calculator out and I'd be showing you on the board. I can't do that with this, so I'm at least going to write down some steps for you, and I really need you to pay attention because you're going to do it on your homework for the weekend, okay? So the first step that we're going to do is we're going to plug into y equals. So what I mean by that is we're going to plug it into y1 equals 4x cubed minus 8x squared minus 11x minus 3. Now remember, I'm trying to factor it. So I'm trying to break that quadratic, or not that quadratic, the 4 terms apart. Okay? It's not a quadratic because the degree's not 2. So I'm going to look, what I'm going to do is I'm going to use my table or my graph. So this is the second part. I'm going to look at table or my graph for zeros. So what I would want you to do is, once you plug that into y1, I'd actually just go to the table. To me, the table's the quickest because you can find them really fast because you're looking at, like, for example, when you plug this one in, when x is equal to 3, y is equal to 0, which means it's a root, right? So once I find that, I'm actually going to divide Remember, x equals 3 is the root, so x minus 3 is the factor. So I'm going to divide x minus 3. Actually, let me rewrite that. I'm going to divide out the x minus 3. And this is what I mean. I would take this 4x cubed minus 8x squared minus 11x minus 3, and I would divide that by x minus 3. Now, I don't want to do all that piece, right? It's long division. So we're going to do synthetic. Remember, that's that shortcut. So remember that the root, so if it's x minus 3 is the factor, the root goes up in the on the little shelf. And then all of these for the negative 8, negative 11, negative 3. So the coefficients and the constants go up here. And then remember how I do this. I bring the 4 down. And then I do 3 times 4 is 12. And then I combine negative 8 and 12, make 4. And I do 3 times 4, and I get 12. And I bring it up here, and I do negative 11 and 12. I do 1, and 3 times 1 is 3. And oh, look at that, there's my root. Now, why am I doing all this? I already know that it's a factor. Because what I just did was I broke down those 4 terms. Okay, so now what I have left is 4x squared plus 4x plus 1. So what that means is, watch this, is x minus 3 times 4x squared plus 4x plus 1 is factors of my original problem. So I'm taking this and I'm breaking it apart. Okay? So I can take it a step further, I bet you. I can factor now this, that trinomial, that quadratic. Okay? So how am I going to do that? I'm going to do the grouping method. Yep, it's coming back. I kept telling you guys we're doing some factoring in this unit. So I'm going to take a times c, which is 4, and then the middle term, which is 4, and I go, what multiplies to b4? That adds to b4. 2 and 2. And so that 4x squared plus 2x plus 2x plus 1. Remember, these become my middle term. Okay, that's my middle terms. And I group them, and I pull out a GCF, and I know I'm going fast, and this is where I better make sure that I see some kids. If you are struggling with this grouping method, I guarantee you will see it on checkpoints in a test. Okay, so I GCF and I get a 2x plus 1 is what I took my GCFs out, and my 2x plus 1 is the inside. And then don't forget, you got to bring this down. And so that becomes my factor. So I kind of got ahead of myself without my steps, with my steps here. We divided out the x minus 3. And then we factored the remaining quad. Okay, what was left is what we factored. And what you have now is the final piece. It's a lot of work, yes, it is. But remember, we originally wanted to factor that problem right here, that up above, that 4x cubed minus 8x squared minus 11x minus 3 that's exactly what we did. We broke it apart into separate factors. Now, what if we took that 4x cubed minus 8x squared minus 11x minus 3 and said, make it equal to 0? Well, we would, again, same problem as A. We would have it in its factor form, and then we would squiggle on each one of these, set them all equal to 0, and solve. right? And then now you have 3 roots. Well, 2 roots really, because x equals negative 1/2 is twice. It has a multiplicity of 2. So when you went up and originally put this in your y1, you should have seen a bounce at negative 1/2, but you couldn't tell what it was from the table. But you could tell x equals 3 was an actual root. That was an integer. Okay, so let's flip it over. Let's do the next one. Okay, so now this one, I gave you the function. And now I want to, so here's my function, and I'm telling you I want to solve it, right? So I gave you the graph to the side here. Now you can see that is clearly a root at x equals 1, although maybe you can't see clearly, but that's what that's there. This is 1, or negative 1, negative 2, so this one right here is 1. X equals 1, so that means it has a factor of x minus 1, right? So x equals 1 is the root, x minus 1 is the factor. Okay, so what we're going to put on our shelf is 1, and we're going to break this apart. Our whole goal is to break this apart. We're doing the same thing, and I kind of sped through this, but basically, this was not factorable. Like if you tried to do the grouping, it wasn't going to work. Okay? So because it's not factorable, that's why I jumped right into looking for a root on the graph, right? And then factoring it out, dividing it out of the problem. So, okay, doing my synthetic. Everybody likes synthetic, so this should be an easy transfer over. 5, negative 0. Okay, so my quadratic that's left, okay, remember how we do this? This is a cube, so this ends up being a 4x squared minus 8x minus 5 equals 0. Right? And then you're going to factor this. Now, this is what I'm going to do. I'm going to leave this. I absolutely, because my lesson on Monday is not really long, I'm absolutely going to be looking at this. I want to see that you finished this problem right here. I'm going to star it. And when I come in on Monday, I'm absolutely going to be checking these to make sure that not only did you watch it, but you finished this problem. So you have to factor this again and solve it, just like we did on problem 1. Okay? And I'm going to leave a couple others throughout here that you're going to do too. So make sure that you are following through with this lesson. Okay, x-intercepts versus solutions. All right. So here's the thing. This is the new piece too. You can have solutions to a polynomial that are not x-intercepts. And those solutions are complex numbers. Okay, so a solution, when we talk about solutions, they're either going to be real numbers or complex. However, x-intercepts out of that can only be reals. So, for example, I can't resist, like I got to put it up here. If I had x squared plus 9, right? And I were to look at that on a graph, it would look like that, right? It would not, has a y-intercept of 9, it never touches the x-intercept. But if I were to set it equal to 0, and factor. Now remember, we did this last unit. This is where you factor where there is an imaginary. So it becomes, this is not a difference of perfect squares, this is a sum. So it's x plus 3i and x minus 3i. So your answer is, there are solutions, but see them right there? They're solutions. There's negative 3i and 3i, but they're not x-intercepts because that graph will never cross the x-axis. So that's what we're jumping into right here. So it says consider the polynomial x to the fourth minus 3x squared minus 4. All right, find the solutions by factoring. Okay. So I'm going to set it equal to 0 because that's how we find a solution. Now look at this here, guys. This is a squared, and that is half of that. So I had told you when we did this in September, which I know was a while ago, is that you can factor this just like normal. So you can just go, okay, what multiplies to be negative 4 that adds to be negative 3? It's, except for instead of an x here, we're going to have an x squared. So the numbers are negative 4 and positive 1. They multiply to be negative 4 and they add to be negative 3. And then we're going to take it and we're going to factor it further. We get an x minus 2 here and an x plus 2. And you have an x minus 1i and an x plus 1i. And if you aren't sure about that, you better go back into your notes when we did imaginaries last unit. Because that's called the, it's a sum of perfect squares identity that we did. Okay, so you're going to set them all equal to 0. X equals 2, x equals negative 2, x equals I, x equals negative I. So when I ask you for solutions, right, we get x equals plus or minus 2 and plus or minus I. Here's our solutions. It does not mean that they're x-intercepts, right? That just means they're solutions. The x-intercepts are only going to be what? Well, of course, I'm jumping ahead again. So it says use the graph to determine the number of x-intercepts for the function. Okay, same function that we just did. What are the coordinates of the x-intercepts? So it means it would cross at negative 2, 0 and 2, 0, right? Those are the x-intercepts. So our solutions to the polynomial equation, p of x equals 0, the one above, the same as the x-intercepts of the graph. No. So only real numbers are x-intercepts. Right? Only real numbers are x-intercepts. The imaginary solutions are not x-intercepts. Okay, so that plus or minus I is not an x-intercept. Okay. You're sticking with me. Keep going. Okay, this is the one you are going to do by yourself. There's another one all by yourself. Checking on Monday. Shout out to the ones that try to scam and don't do that. You're going to do it. Going to check it on Monday. Okay, so I'm leaving that one. All right, so I'm just going to give you a little recall here on the remainder theorem. Remember that the remainder theorem is the function value at c equals the remainder when you divide by x minus c. So, for example, consider the polynomial here. P of x, right? I got a new one. Put this into y1. Take a minute and put this into y1. Go, 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 go. Put that in y1. I'm waiting for you. Put that in y1. Okay? So, if I were to divide this by, for this first one it says, is negative 2 is 0 of polynomial p. If I were to do x plus 2 divided by 2x cubed plus 5x squared minus x minus 6, go to your table and look to see. What is p of negative 2? What is the result? What is the y value? You should see 0. So if I were to do this division, right, then the remainder is 0. Okay? If I were to do the division with x plus 3 divided by all that, right? I'm going to divide all that out. The remainder, okay, the remainder down here would be whatever p of negative 3 is. So look at p of negative 3 on your calculator. It's negative 12. That is your remainder. If I were to make you do that line division, okay? So you can use that whole theory with the remainder theorem, right? By you could literally just plug in the negative 3 into the equation, and it pops out negative 12. When you do that, you know that the factor x plus 3, or the potential factor x plus 3, is not going to work in here, right? But for a, because it has a remainder of 0, x plus 2 is a factor. Okay? So, use your answers from above to write the equation of p in factored form. Okay. So, here it is again. I'm going to make you do it again. Come through there. I'll set it up for you. I'll even be nice. I will set it up. Find the factored form of that p. So we know this one's going to work. Do your line division, break it down, right, and then factor it again. Factor it so that I will give you a clue. There will be three of these left when you're done. So I want this p of x in factored form. Here's my other star. You're going to do this one by yourself without me. Okay, here's my last one, my grand finale here. All right. 6. The graph of p of x is shown below. I'll show it to the right. Determine p of negative 3. Okay. So, or p of negative 4. I don't know why I said negative 3. I was looking at b. So, p of negative 4. So, go to where x is 1, 2, 3, 4. Right? And I have 0. So, x plus 4 is a factor. It has a remainder of 0, right, if I were to do the division. So it actually says, what is the remainder when p of x is divided by x minus 3? Okay, so this is when x is equal to 3. So I go 1, 2, 3. When x is 3, I get 0. Okay, so is x plus 2 a factor of p of x? So isn't this when x is equal to negative 2? Right? So go to 1, 2. Go to where negative 2, and I go up 1, 2, 3, 4. I see that p of negative 2, if that's the input, the output here is 4. Right? So that has a remainder. Once I plug that in, it has a remainder of 4. So we're going to say no, because p of negative 2 equals 4. So I got to write the equation of the function. And oh, wait a minute, they gave me this note that the graph passes through this point. Okay, so I can tell, because I've done this enough times in here the last couple days, that I have 3 roots. They all cross, right? So I've got x is one of mine, right? Because it crosses a 0. I've got x plus 4, and I get x minus 3. Because at negative 4 and a positive 3 are the other roots. All right. Now, they give me that info for a reason. They want me to find a k value. So remember I told you the other day, when they give you a point, you got to make sure that it actually goes through that point. So this becomes my negative 2. And all the x's become 1. Okay? And you're going to finish this one. You're going to tell me what the k value is, and then you're going to write the function in factored form. You don't have to put it in standard form, but finish it up in factored form for me. Okay? Alright, good job. That was a lot. I know it was a lot. Thanks for sticking with me here. I think I lost my... Oh, there it is. And I will see you guys on Monday, okay? Make sure you get your homework done. Have a good weekend, okay? Talk to you soon.